Some functions are explicit functions, meaning they're solved for y equals something, or f of x equals. Those are explicit functions. Some functions are implicit, meaning the x's and y's are all mixed together in one equation. We know how to find the derivative of a lot of explicit functions now. We know the product rule, the quotient rule, the chain rule, things like that. But what happens if we have an implicit function with x's and y's on the same side? How do we do that? How do we tackle that? Do we want to solve for y? Well, that's a lot of work sometimes. So we want to find a way to find the derivative of y prime, or dy dx, without solving for y. And we have a very useful technique called implicit differentiation. So let's look at some implicit functions with x's and y's on the same side and see how we can find the derivative without going through all the hassle of getting y by itself. Let's check it out. So the implicit differentiation here means we got to take and find the derivative of both sides. All right, so we got some steps here. Our steps are going to be to find the derivative of the left side and find the derivative of the right side, and then we're going to evaluate with derivative rules and solve for dy dx. All right, let's try it out. So the first thing we're going to do is take the derivative of the left side here and the derivative of the right side. Right side is going to be easy. The left side will take a little more work. So the right side is 0. And the left side, well, we're going to break it up into two parts. Let's take the derivative of x squared. And then we're going to need the derivative of y squared. Derivative of x squared, we're used to that. That's just 2x. But the derivative of y squared, we got to think a little bit more about here because y is a function of x. We don't exactly know what it is. We could solve that thing up top there, but y is a function of x, so we're going to need the chain rule here. So to use the chain rule, we've got to derive the inside and the outside. Okay, we could solve for this y here, but we want to avoid that. So just think of this as a function of x, and we'll treat it as an unknown. We'll take the derivative of the outside, take the derivative of the inside. So we're going to add, derivative of the outside is just 2y. The times the derivative of the inside, well, it's y. Y is a function of x. I don't exactly know what it is, but we can say that it's going to be dy dx. Okay, some function of x, and where that's the derivative. Now that's what we're trying to solve for, dy dx, right? So we're going to get these other things out of here. Let's get the 2x out of here. Let's get the 2y out of there. And so let's subtract that on over 2x from both sides. That gives us 2y times dy dx, the thing that we're going for. Now we got to get that 2y out of there. It's just being multiplied. So the opposite of multiplying is dividing. So let's divide it. All right. And then we get just a simple negative x over y. All right. We found the derivative without actually solving for y. Great. Well, now we're going to use that. And we're gonna find the tangent line. Again, the key at the steps, take the derivative of both sides, evaluate using the rules, and then solve for dy dx. Now, let's go use this and find a tangent of it. So we know dy dx for this function is negative x over y. So here's the same function. I'm going to copy that down. Dy dx is negative x over y. I already did that work. The question now is we want to use implicit differentiation to find dy dx. Already did that. Then we're going to find the equation of the graph at a given point. And we want to find the equation of the tangent line at that given point. We can check with Desmos. So, all right. Well, we know the function is negative x over y, which feels a little weird because we have an x and a y in there, but that's going to be just fine. So we're going to evaluate this at 3, 4. We've got a point on this circle, 3, 4. And so we want to find dy dx at that point. So it's going to be negative 3 over 4. And that's our slope, right? The derivative is the slope. So if I come over here to this point, I can use rise over run, negative 3 over 4, and we can find some other points, and we go up and over as well. So negative 3 fourths puts us here. And then if I go up 3, left 4, kind of going backwards, I got another point. So now I can draw my tangent line in here. And we can see that the line looks about like this. Yeah, it looks pretty close to tangent. All right, touches at that point, did it freehand. So the equation of the line is y minus y1, well, what's our y1? It's 4, equals the slope times x minus x1, which is 3. There we have our tangent line. Great. Well, let's go ahead and check our next line out here. Actually, before we do that, let's go ahead and try graphing this here. So we've got x squared plus y squared equals 25. We can go to Desmos, handy tool for doing this. There's our tangent line. Now we need to type the equation of that. I'm sorry, that's not our tangent line. That's our circle. And there's our tangent line. Y minus 4 equals negative 3 fourths times x minus 3. Okay? So we graph our circle and our tangent line. Yep, look, they touch at exactly 1 point. So we got it right on. Let's try the next one here. So here we have a function, a little larger function, more steps. We're going to take the derivative of both sides. That's our first step. Remember that y is a function of x. So the right side's easy, that's 0. The left side, well, let's break it up. Derivative of y squared. Take the derivative of the outside, that's 2y. And then we got to remember to take the derivative of the inside. So 2y for the outside. And the derivative of the inside, it's y. Y is a function of x. Don't know what that is, so it's just the derivative of y with respect to x. Then the other terms are pretty straightforward. We know how to take the derivative of x cubed. It's going to be 3x squared, right, with a minus. And we know how to take the derivative of 2x. That's just 2. Now remember, we're trying to solve for dy dx. So we got to get this stuff out of here. So we'll add over the 3x squared and subtract over that 2. All right, now we're trying to solve for dy dx. That's being multiplied, so we'll divide by 2y there on both sides. And we have our answer for dy dx. Notice that we got an x and a y on that right side. And that's going to be okay for us because we are looking to find the slope of this tangent line. Our ultimate goal is to find the equation of the tangent line. So to find the slope, we're going to evaluate dy dx at 0, 1. So let's plug those things in there. Dy dx evaluated at 0 over 1. This line means evaluated at 0 over 1. Just plug it in. Plug in 0 for x and plug in 1 for y. Okay. That's going to be 0 minus 2 all over 2. So we can evaluate that. A little negative 2 over 2. And that should give us negative 1. So we got our slope. Now our goal is to find the equation of the tangent line. I'm not going to graph this one, but we just use point slope, y minus y1, which is 1, equals the slope, negative 1, times x minus x1, which is 0. We could leave it that way, but it might be nice since it's got that 0 there. Let's put in the slope-intercept form. It's negative 1x, maybe y equals negative x plus 1. Just need to be able to recognize it in different forms. So there we have it. That's the slope of the tangent line at the point 0, 1. Well, let's try a little more complex one. What if we throw some trigonometry in it? Okay, so we want to find, we got this equation. You're going to pick the point, okay, or where I'll pick it here for this video. And then we'll find the equation of the tangent line. So let's make it easy on ourselves. Why don't we pick x equals 0? 0 is always nice. So if we substitute 0 in for x, then we should be able to solve for y. So 0 sine y plus y cosine of 0 equals 4 pi. Okay, that first one's going to go away because 0 times that. Cosine of 0 is 1. So this just becomes y equals 4 pi. Well, that was not too tough. So we got a point on this graph, 0, 4 pi. There's obviously countless points on this graph, but 0, 4 pi was an easy one to find. So now we got our point. Let's go ahead and find our derivative with implicit differentiation. We're going to take the derivative of both sides. And we'll have to do that implicitly. Got a couple terms here to deal with. So our first term, we've got x and a sine y here. So we're going to have to use the product rule. Okay, there's two parts. There's an x and there's a sine y. So we got to take the derivative of the u, or the first part, that's 1, times the second, which is sine y, plus the first, which is x, times the derivative of sine y. Now that's implicit, because it's not sine of x, it's sine y. So we got to take the derivative of the inside. Well, the inside is y, so we're going to have, dy dx, and the derivative of the outside is cosine y. But don't forget to take the derivative of the inside, that's dy dx. Okay, now that's just the first part. So I'm going to move this little 0 over here. And we're going to have to take the derivative of the second part here. We've got a y and a cosine x. So the derivative of y, the first part, well, that's dy dx. And then we're going to have to use our product rule. And that's derivative of the first times the second plus the first, which is y, times the derivative of cosine x. That's an x, not a y. So we've got a negative sine of x. And that's that. So we need to get dy dx, so we're going to kind of clean these terms up a little bit here and rearrange a bit. Notice that it's all plus. There's nothing to be distributed. These are the terms we need to keep, and we're going to move all the others to the other side. So this is nothing to distribute, just plus. All right. And so we're going to get that sine y out of there. That's a positive sine y, so let's subtract that from both sides. And then we've got this negative sine x times y, or negative y sine x. Let's add that to both sides. We're going to get a plus y sine x on the right side. And then we have these leftover highlighted ones that we'll copy down. X cosine y dy dx plus dy dx cosine x. We're trying to solve for dy dx, so we got to factor that out. So we're going to pull out the dy dx, because that's what we're going for. And we're left with x cosine y plus cosine x. Okay. Just copy the right side down here. Now, we're trying to solve for dy dx, so this is multiplied, so we're going to get rid of this parentheses here. We've got to divide both sides by this cosine y cosine x binomial there. So dy dx, we're going to divide both sides by x cosine y, so we got the right side, negative sine y plus y sine x. I'm going to divide that by that binomial x cosine y plus cosine x. It's ugly, But there it is. We found the derivative. And that would have been pretty much impossible to find y. So the key is to get dy dx by itself and then divide it over. Now we want to find our equation still. Our point was 4 pi. So we got to plug that in. So the derivative is at 0 at 4 pi is negative sine of 4 pi plus 4 pi times the sine of 0 all over 0 cosine of 4 pi plus the cosine of 0. So let's use our unit circle. Think about the sine and cosine. Remember that 0 and 4 pi are really the same angle. They're over here on the right side, landing on the axis. And so the sine and cosine there, that's the 1 comma 0. So the sine is 0, so that goes away at 4 pi. And the sine of 0 is 0, so that term goes away. And the cosine of 0 is 1. This other term is going to be gone because that's 0 times cosine of 4 pi. So we have 0 on top, we have 1 on bottom, which is 0. So now we're going to go find our tangent line here. We're going to use our point slope form. And we went through the point 0, 4, so y minus 4 pi, that is, equals the slope, which is 0 times x minus 0. So the right side just becomes 0. And we can add that 4 pi on over. And we got y equals there. Or we'll just call that y equals 4 pi. So that's the idea there. We're going to stop the video here because it's getting a little long, and we'll do the second derivative part here for the second video.